Example 1, we're trying to find the distance between two inaccessible points A and B. So basically, this surveyor is trying to measure the distance between these 2 points. Okay? And they're going to end up using the law of cosines to do that. So we're finding the distance between points A and B. That's side C, by the way. So it says, while standing at point C, she finds that AC is 259 and BC is 423. So they can actually measure those distances. And they also measure that angle C in between them is 132 degrees and 40 minutes, or 132.6 repeating degrees. Okay, right? When we change from minutes to decimals, take that 40 and divide by 60, that's going to be 0.6 repeating. So what I would encourage you to do is think about Temple Run and think about that guy running around and collecting tokens. Look at what you've got. I see a side and an angle and another side. When you see SAS, SAS is going to indicate that we're doing case 3, law of cosines. Case 3, law of cosines. So always look for that. Now here's how the law of cosines is going to work. You want to find this partnership between a side and an angle. Because those two things are going to be represented in this formula. The formula, we're going to find C squared, or C, and C squared is going to equal A squared plus B squared minus 2AB cosine of angle C. So we ought to just be able to plug in almost everything. We can plug in A, side A was 423, so 423 squared plus 259 squared minus 2 times 423 times 259 cosine 132.6 repeating degrees. We just have to input all that into our calculators. So let's see. C squared equals, or is approximately anyway, 394510.567 or something. And so let's end up by taking the square root of that. C is about 628. What are the units here? Meters. Example 2, we're solving a triangle. So I'm going to start by drawing the triangle. Angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. So when I look at this triangle, I identify that I'm looking at a side, angle, side. And side, angle, side tells me that this is case 3, and I know that's the law of cosines formula. Okay? So where do I start? I'm going to establish a partnership with this angle and find the side across from that angle, and that's side A. So if you're looking at your formula, A squared would equal B squared plus C squared minus 2BC times cosine A. So then let's plug in. B is 12.9, C is 15.4, and angle A was 42.3 degrees. So one of the biggest obstacles is, can you type that into your calculator? So let's all practice. Let's type that in and see if we can come up with the right number here. Make sure we're in degrees. Did you get about 109.7? So that's not the answer, because we're still going to have to take the square root in order to find A. Normally we would do the plus or minus square root, but we know since we're talking about the side length of a triangle, it's not going to be the negative square root. Also, I wrote down 109.7, but my answer is actually 109.6997733, and so on. So I'm going to leave that number in the calculator and just use that number, square root of that number in the calculator, about 10.5. So now I'll round off. A is about 10.5 meters. Now, we're solving the triangle, so that means we have to find all of the missing parts. Right now I just found this side, but I still need to find these two angles. Okay? Now, you have your choice. At this point, you could either find angle B or you could find angle C. And it makes a difference which one you choose. Okay? What we want to do, you have to trust me on this for a second, but what we want to do is pick the smaller of the two angles. Okay? So look at angle B and look at angle C and tell me which one's smaller of those two. Angle B. Okay? Angle B, you can tell because angle B is across from 12.9, angle C is across from 15.4. You can tell that the largest angle is across from the largest side. So I want to find the smaller of those remaining angles. I'm finding angle B. And what we're going to do is we're going to go back and use the law of sines in order to pick that up. Okay? The key for that is, again, this relationship between angle and side. We're going to say sine of angle B over 12.9 is equal to, and we already have a partnership established over here with A. We'll do sine of 42.3 degrees over 10.5. So we had to go back and use the law of sines formula. We're going to do what we did in 8.1. Either think of it as cross multiplication or multiplying both sides by 12.9, but we're trying to isolate B. We would have sine B equals 12.9 times sine 42.3 divided by 10.5. Sine B is equal to that, 0.8268. 0.8268. And so we're going to do an inverse sine. Inverse sine to isolate B, inverse sine of that number on my calculator is about 55.8. Okay, now here's kind of the tricky thing. Once we do this once, we won't have to do it again, but I need to explain it first. That 55.8 is the reference angle where sine is positive. So we've done this a number of times. It's kind of tricky. Sometimes we forget. But that's really, the answer to that equation is really two different angles. And so we would do a 55.8 where sine is positive is going to either be in the first or the second quadrant. Now look at the second one. The second angle is going to be 180 minus 55.8, 124.2. Okay? So what we have at this point, B either equals 55.8 degrees or B equals 124.2 degrees. Okay? But 124.2, if that were in a triangle, if you had an angle of 124 in a triangle, that's going to have to be the biggest angle in a triangle. Does that make sense? Do you agree with that? Yeah. It can't be anything bigger than 124. But remember the decision that we made earlier? We specifically chose to find angle B because it was not the biggest angle in the triangle. Okay? And so there's this contradiction, meaning that this can't possibly work. That angle B can't be the biggest angle in the triangle because we chose it that way. We chose it that way. And so we don't even really, when we're doing law of cosines, we won't even really need to look at that second one because that's never going to work. That's never going to be the case. And so here we are. We've got angle B is equal to 55.8 degrees. Angle B is equal to 55.8 degrees. The only thing I don't have yet is angle C. That's going to be pretty easy to figure out because I can just subtract from 180. Subtract off angle A and subtract off angle B. Is anybody ahead of me? 108.9? 81.9? 81.9 degrees. So solve the triangle. We needed to find the missing parts. There they are. Now down at the bottom it says caution. If we had chosen angle to find angle C instead of angle B, we would have a big problem because angle C was the biggest angle in the triangle, and so angle C could have been that 124. We wouldn't have known. We wouldn't have known whether to use the 55.8 or the 124.2. And so that's why it's going to be so important for us to pick the smallest remaining angle when we're doing our law of sines in this one. Example 3 has us solving another triangle, so I would try diagramming it again. But notice side A is 9.47, side B is 15.9, and side C is 21.1. Pretty obvious this time we've got side, side, side. That's going to be case 4, law of cosines. Case 4, law of cosines. So, I need to find an angle, and it doesn't really matter where you start. Let's just start with the smallest one, and notice kind of a partnership here. If you want to find angle A, then you got to notice that that's across from the smallest side. And so how I would set this up is I would say 9.47 squared is equal to 21.1 squared plus 15.9 squared minus 2 times 21.1 times 15.9 cosine of angle A. So again, I think the most important thing to notice is that side A is on the far left and angle A is on the far right. Make sure you put the numbers in the corresponding spots. Okay, so I have to solve for angle A. I think the easiest thing to do is to manipulate the algebra in your head ahead of time. Okay? I don't want to have to type in a whole bunch of different numbers into my calculator and then use those numbers into new numbers. So here's what I will do. I want you to really focus on the algebra. I'm doing some mental math here. If I was going to isolate A, I would have to subtract these two things over. Okay? We're going to subtract those two things over, and then we're going to divide by that negative 2 times 21.1 times 15.9. Okay? So kind of in my head, I'm rearranging the equation to where it would say 9.47 squared minus 21.1 squared minus 15.9 squared divided by negative 2 times 21.1 times 15.9. Okay? Trying to isolate the variable. But I move all those numbers away, and I've got cosine A by itself. And so I'm going to type all that stuff into my calculator all at once. Now what you have to do, though, in order to type this in correctly, you're going to want to put parentheses around the top and parentheses around the bottom. Okay? And so it's going to be all that stuff in parentheses on the top divided by all that stuff in parentheses on the bottom. Very important that you utilize the parentheses correctly, otherwise it's not going to come out right. So let's all try to type this into our calculators and see if we can get the right number. Fingers crossed. Start with parentheses though. Close parentheses around the top and divide by quantity on the bottom. .9066 is what I got. Hopefully that's what you got. 0.9066, and we're not finished. That's not the answer because we haven't completely isolated A yet. The next thing I would have to do is what? Inverse cosine of that. Okay? So inverse cosine of that. What? That's not right. Roughly 25? Okay. Now, technically that's a 25-degree reference where cosine is positive. Okay. However, we don't really care about that. If you look at 25-degree reference where cosine is positive, that gives us a 25-degree angle, or that second one will be 335. Can we possibly have an angle of 335 inside of a triangle? That's never going to be possible. The second answer to that equation is never going to fit in a triangle, so we can always ignore it. So A is just going to equal that 25 degrees. And so I might go ahead and label my picture with the 25. And then we're going to have to do law of sines to figure out the next angle. Okay? Remember what I said though. When you've got your choice of either B or C, pick the smaller of the two angles. So which angle is the smaller remaining angle? B. So let's find that smaller remaining angle. Sine B over 15.9 equals, we're going to use our A values because we've got them both. We've got the angle of 25 and we've got the side of 9.47. So if I was going to solve that equation, I'm going to multiply up. I'll multiply both sides by 15.9, I guess. It's going to look like 15.9 times sine 25 divided by 9.47. About 0.7096. I like rounding to 4 decimals. Sine B is about 0.7096. Now I would write down 0.7096, but I leave that whole number inside my calculator for the inverse sine. We take the inverse sine of that number and get about 45.2. Okay. Angle B is going to be 45.2. Now keep in mind, we chose B. We chose to find angle B because it was not the biggest angle. And so the fact that it's not the biggest angle means that we don't even have to look at that other angle. Okay? So don't even worry about finding that second angle. We're never going to have two triangles here when we do law of cosines. Okay, so I've got B equals 45.2. Should be easy to find the third angle. You just subtract from 180. Angle C is going to be 180 minus 25 minus 45.2. 109.8? Okay, good. C equals 109.8. And there we are. Example 4, we're finding the measure of angle B. And so here's angle B. you look at what you have in the triangle, and I've got a side and a side and a side. I've got side, side, side. Side, side, side tells me case 4, law of cosines. I know I'm using the law of cosines formula. But here's how the setup goes. We're finding angle B, so match it up with its part. Angle B is going to go with that side 6, 6 feet. And so when we set up, it's going to be 6 squared equals. The other two don't really matter what order. There's going to be your setup. Okay? So I think the easiest thing to do is to recognize that we're going to subtract these over, and we're going to divide by this. We've got 6 squared minus 9 squared minus 11 squared, all over -2 times 9 times 11 equals cosine B. So type that in real quick. Somebody tell me what you get to 4 decimal places. Point 8383.
No, technically 8384 because it rounds up.
Is it 3 or is it 4?
4.
Okay. 0.8384 equals cosine B, and then what do we do?
Inverse.
Inverse cosine. Inverse cosine. Okay. Inverse cosine on both sides is going to tell me what B is. And so B equals 33. No decimal point?
0.02.
0.02. Okay, so let's just call it 33 then. 33 degrees. And that's it. Now, I don't know if anybody considered this, but when you did that inverse cosine and we got 33, did anybody think that that's a reference angle where cosine is positive? Okay, it is. That is a reference angle where cosine is positive, but if you think about it, cosine is positive over here and over here. So there's a 33-degree angle, or all the way around is what, 327?
Yeah.
How do we know that that can't work?
180 half.
Triangle has 180 degrees in it, so it can't possibly be 327. And so we won't ever have to deal with that second angle. We won't ever in cosine, because it's always going to be in quadrant 4. It's never going to work, and it's always going to be too big. So as soon as you get your 33 from your calculator, that's going to be your first quadrant answer. That is the answer. B equals 33. Don't even worry about doing this stuff. Herman of Alexandria is kind of an interesting historical figure. Okay, he was a mathematician and he was an inventor. He invented all kinds of really cool things thousands of years ago. This is a picture of his steam engine, basically. Steam engine. I don't know that it really did a whole lot of work, but it was kind of neat how it works. If you are into history and inventors, check out this guy. Look him up. He did some really cool things. But one of the mathematical things that he did was he came up with a formula for area of a triangle. Okay, area of a triangle if we know side, side, side. So what he did was he talked about something called the semi-perimeter. Semi-perimeter is kind of a weird kind of concept that we've never really had to deal with, but semi-perimeter just means half the perimeter. Half the perimeter, that's not very hard to find out, especially since we know all of the sides. But semi-perimeter is half the perimeter, and once you know that, then his formula looks like this. The area of a triangle is going to be the semi-perimeter times S minus A times S minus B times S minus C, all of that inside of the square root. Okay. Big square root. So when we look at example 5, notice they've drawn a triangle. and they've given us the 3 sides. So if we know side, 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 we should be able to find the area of that triangle using Heron's formula. So first thing we would want to do is find the semi-perimeter. Semi-perimeter is half the perimeter. So perimeter, we'd add up the sides, add up those 3 numbers. Double check me here, but I think it's 5,209. Somebody add that up real quick. Okay, so half of that perimeter is 2,604.5. That is not the answer. That is not the area. That's the semi-perimeter, or half the perimeter. We're going to use that number to find area. So, according to Heron, area is going to equal big square root. Big square root. The semi-perimeter is 2604.5 times the semi-perimeter minus side A times the semi-perimeter minus B times the semi-perimeter minus C. We just need to be able to type that in. So square root of 2604.5 times parentheses. Close off the whole thing. Square root of all that stuff turns into 401,664 approximately. So we're talking approximately 401,664 square miles.